Good morning, Tahmina Khan is here in TKMaths S1. In today's video, we will solve another challenging question of permutation and combination. It's a past paper question, and this topic is from the syllabus of A-level mathematics S1. So here you can see the formula which is used sometimes when there is n or unknown value. We cannot use calculator straight away, then we need to use these formulae. And you can see a very important relationship here which is often applied in the solution. So let's see the question here. This question is about a committee of 6 people. Now let's start highlighting the important points. Okay, let me change the color. Okay, so the committee should have at least 4 men, at least 1 woman, and how many are there? From 10 men and 10 women. So let's write down information here so that we remember it. 6 people we have to select. Okay, so there are 10 men and there are 9 women. From the 10 men, we have to select greater than or equals to 4 men. So this is the symbol I'm writing to tell myself, right? Rather than reading question again and again. And then from the women, there should be at least 1 woman, right? So this symbol I'm using for myself, that number of women should be 1 more. Let me write here, W. Okay, so let's solve part 1. Find the number of possible committees that can be made. Now this is a straight away question, very straightforward. Because I have to select 6 people, so one possibility is that I have 4 men and I have 2 women. Or I have 5 men and 1 woman. Now I cannot take 6 men and 0 women because at least 1 woman must be there and at least 4 men must be there. So this is the only possibility. So now I will write it in the combination form. Because there are 10 men, I will write 10C4 into 9C2. When OR comes, we use plus, right? Again 10C5 because there are total men 10 and from them I have to select 5 men. Okay, into 9C1. So now you can use your calculator. Let me use it. Okay, so answer is 9828. So question was asking find the number of possible committees. So 9828 committees can be made, which will be following these conditions. Okay, now so now part 2. Part 2 is saying find the probability. Now we have to find out the probability, right? That one particular man, Albert, and one particular woman, Tracy. Okay, so there is a condition, are both on the committee. So now let's see here, 1, 2, 3, 4, 5, 6. Okay, so these are the 6 possible committee members in which Albert and Tracy have been selected. So they have told you here in this that they are included, okay, in part 2 here. Let me remove not here. Okay, so now I have to select what? 4 more people, and condition is same because this condition which is given on the top will apply in all the 4 parts of the question. Okay, so now because 1 man and 1 woman has already been selected, so if I look at this condition here, okay, condition was supposed to be 4 men, 2 women, or 5 men, 1 woman, right? If I see from this condition, now 1 man is already selected, which was Albert. So now I have to select 3 men. And similarly from 2 women, 1 is already selected. So I have to select 1 more woman, right? So for this it will become, one more thing here. If you see from the 10 men, I can minus 1 now. Why? Because Albert is selected. So now total men, remaining men are 9. And from the 9 women, Tracy has already been selected. So now there are remaining 8 women. So now my selection will be done from this. Okay, so I have to select 3 more men. So I will say 9C3 into 8C1 because 8 women are left and I have to select only one, right? Now OR is plus. Now second condition was 5 men and 1 woman. So from 5 men, 1 Albert is already selected. So I have to select 4 more. And 1 woman which I have to select it, Tracy is already here. So 0 women now. Okay, so now men are remaining 9. So I will say 9C4. And there is no women required. And that's all. So now if we calculate, let me calculate it. It will be 7, 9 and 8. Now these are the cases with this condition in which Albert and Tracy are in. But what was question saying? Find the probability. So what we have calculated is a numerator. Because when we write probability, it is in fraction form, which can be changed into decimal form. So now if I see, my denominator would be total number of cases in which there are at least 4 men and 2 women. So which was part 1, 9, 8, 2, 8. So I will write that in my denominator. And you can write in the simplified form if it comes, otherwise in the decimal. So this is the probability when Albert and Tracy are in the team, in the committee. And at the same time, we have to see the condition of at least 4 men and at least 1 woman. Okay. Now let's see part number 3. Part 3 is find the number of possible committees. Now this is not about probability, okay? Find the number of possible committees that include either Albert or Tracy. So one case is Albert in, Tracy out, or second case is Albert out, Tracy in. Okay, so 1, 2, 3, 4, 5, 6. Now Albert is in. Okay, so now we had here 10 men. Okay, so from 10 men, 1 is minus. Reason is Albert is in, so remaining men are 9. Okay, similarly Tracy is out, so total women were 9. It was written here in the question, yeah, first line. Okay, so from 9 women, Tracy is out, so remaining women are 8. So now we will make our selection from here. Okay, so I'm writing the same condition again, the condition which we have seen here, 4 men, 2 women, or 5 men, 1 woman. The condition will remain same every time because we have to fulfill the requirement given up here. So if you see, sorry, pen is gone. If you see 4 men, 2 women, or 5 men, 1 woman. Now let's see what is in from here and what is out from here. Okay, so from 4 men, Albert is already in. Okay, so now I have to select how many more? 3 more. Okay, I have to select 3 more. And women I have to select 2. Okay, Tracy is out, but I need 2 more women. So how many men were here? 9. So I can say 9C3 into 8C2. This I have taken from here. Or mean plus. Again, second condition, which was 5 men and 1 woman. 1 man is already in, which is Albert. So I have to select 4 more. So from 9 I will select 9C4 into remaining women were 8 because Tracy is out. So 8C1. So this is the case when Albert is in, and if you calculate it, let me calculate it in the calculator. So it is 3360. Now let's take the second case when Albert is out. 1, 2, 3, 4, 5, 6. Okay, now Tracy is in. Okay, so now if Tracy is in, so let me write here, and Albert is out, so I have 10 men minus 1 because Albert is out. So now my selection for men will be done from remaining 9. And there were 9 women. Tracy is in, so I'm subtracting it. Now remaining selection will be done from the 8. So again I'm writing the basic condition: 4 men, 2 women, or 5 men, 1 woman. Okay. So let's see the first case. For the 4 men, I need to select all 4, right? So remaining were 9. So I will do 9C4 into, now I will not select 2 women, Why? Because Tracy is already in. So I have to select only 1 more woman. And there are remaining women 8. 8C1 plus. Now from 5 men, I have to select all 5 because Albert is out. So from 9. So 9C5. Now this 1 woman, actually there is 0 required because Tracy is already in. So no need to take any women. So now when you calculate it, you will get 1, 1, 3, 4. Okay, so you can add these two results and the result will be what? Result will be after adding this one and this one. So result is 4, 4, 9, 4. So this is the number of possible committees in which either Albert is there or Tracy is there. Now let's see the last part. Part 4. The committee that is chosen consists of 4 men and 2 women. Okay. They make a queue. So committee has been selected. 1, 2, 3, 4. So 4 men and there are 2 women. So committee has been selected and now they are making a queue randomly for refreshment. Find the probability that the women are not next to each other. Now we have to separate women. Okay. Now because it is probability, okay, so denominator will have all the cases. So altogether they are 6. 4 and 2 is 6. And they can stand in any order, which means 6 factorial. That is denominator. But for numerator, we have to separate women. Like I said in my earlier videos, whenever you have a case of separate, please do follow just one procedure, and that is those you are separating, forget them for the time being. So I will draw 4 dashes for 4 men. They have no problem, so it is 4 factorial. Women who need to be separated must be in between or in the beginning or in the end. Only then they can be separated from each other, right? If they will be coming between where men are standing or in the beginning or end. So the possible positions are 1, 2, 3, 4, 5. So out of these 5 positions, they can fit on any 2 position. So that will give you the chances or the ways in which women can stand not next to each other in a queue. So this will be 4, 8, 0. So you can write here for the calculation of the probability, and that will give you the answer 0.66666, which means 0.67. Okay. Or when we write answer in 3 significant figure, you can write 0.667. So I hope you will understand it was a good, interesting question. You can press like and subscribe button and share it with your friends. Thank you very much for watching. Take care. Bye bye. Allah Hafiz.